Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to all. My name is Muhammad Akil bin Muhammad Noor, a 3 SMJM student, and I will be presenting my final year project, which is about buckling analysis on Kenaf sandwich reinforced composites. This study is supervised by Dr. Zainuddin bin Abdul Rashid and co-supervised by the head of IDS ICOSA, Professor IRTS Dr. Aminuddin bin Haji Abu. Without further ado, let's start with a little bit of introduction. Our world is filled with structures which are made of composites. Composites are reinforced mostly by using synthetic fibers such as glass, carbon, or even silicon carbide. These synthetic fibers are used in manufacturing of sandwich panels which are strong towards compressive and tensile forces. Sandwich panels are perfect for applications where high stiffness and low structural weight is required. You might be wondering, what are sandwich panel composites? Well, to begin with, sandwich composites are composites that are made of a material which has a simple lightweight core, which is made of polymer foams, or expanded metal, or polymer honeycombs, that is sandwiched on either side of the core. These sandwich panels or skins are usually made of materials which has high strength such as aluminum, titanium, or fiber-reinforced polymers. However, nowadays, synthetic fiber resources are depleting. Engineers must strive to look for an alternative, and at the same time, with the development of technology in the world, green technologies are being sought out by manufacturers and consumers. Natural fibers have been looked by engineers as a potential substitute. However, some engineers are dubious on their mechanical properties if natural fibers would be on par with synthetic fibers, especially in sandwich composites. That is the focus of my study. Now, when designing strong structures, engineers cannot escape from certain deformation which must be taken into consideration, either it is a threat or can be ignored. This study focuses on one of those deformations, specifically buckling. Buckling happens frequently, especially towards thin composites in a structure. Sandwich panels are not an exception. Buckling happens mostly due to compressive loads which towards the structure. In layman terms, buckling is a failure of a structure member experiencing high compressive stress which causes a sideway deflection. Why should an engineer be concerned with analyzing the buckling of a structural member? Once a structural member starts to buckle, any further load will cause significant and unpredictable deformation. Analysis is done to find out the highest buckling factor, in other words, the critical load to be considered to that the overall structure can reach stability and avoid failing. In this study, I will use ANSYS APDL, a finite element method software, to study buckling based on two methods. The first is linear buckling analysis, or LBA for short, which utilizes eigenvalue equations to find the critical load of a model. LBA can be used on simple structures only. The second is nonlinear buckling analysis, or NLBA for short. It's by graphing the forces acting on the graph against lateral deflection curve based on a single buckling mode. NLBA can be used on simpler and complex structures. The study's methodology is based on the flowchart on the left side, from modeling to meshing, then to conduct stress analysis on the model, then doing linear buckling analysis using eigenvalue equations to find its critical point for a certain number of modes, and finally, to perform non-linear buckling analysis on the model using information gathered from the linear buckling analysis earlier. An example on the simulation done can be seen on the results of linear buckling analysis towards an isotropic plate. This plate was applied 4 different buckling modes, each with different forces applied as seen in the table on the rightmost side of this slide. The units are in pascals. The focus of this study is to convince future engineers to consider natural fiber reinforced composites in their design for future innovations. The objectives, on the other hand, are to determine the critical load of sandwich panels composite using finite element method. Next, to conduct nonlinear buckling analysis on sandwich panels, and lastly, to compare the critical loads value from linear buckling analysis and the estimation from nonlinear buckling analysis to see its accuracy. The scope of this study is limited to a few items. This study is conducted completely through ANSYS APDL. Only sandwich composites with foam cores are considered. Buckling analysis is only done on the skin of the sandwich composites. Only rectangular plate shapes of sandwich panels is considered. Shell elements in ANSYS APDL is used for analysis in this study. And lastly, practical testing will not be conducted due to financial constraints. That is the end of this 5-minute thesis. That is all from me. Goseichou arigatou gozaimashita.